Hey, good afternoon, ladies and gentlemen, and a happy spring. Welcome back for those of you who've ventured south to warmer weather for spring break over the past few weeks. I hope you all had safe travels while having a memorable trip with your family and friends. Now that you're back at the grindstone, I'd like to thank you for taking the time to join us today for another Kendall Connection Live on SensoPart. My name is John Bain, and I'm a drives and motion automation engineer headquartered in Grand Rapids. I support the lower half of West Michigan from the Indiana border all the way up to Ludington, along with Ross Scoma and Steve Swales. For those of you new to the Microsoft Teams Live format, I'll do a quick overview. In the top right, you have the questions and comments button. Please select this to display the live Q&A tab. The featured option will show all published questions and comments during the presentation. My questions will show only those you have entered. To ask a question, please click on the Ask a Question button located in the bottom right-hand corner of your screen. On our agenda today, we have Justin Lundberg leading off with a few product highlights that might be of interest to you. On deck is Mr. Randy Carlson, who will provide a SensoPart product overview. In the three-hole, we have Vision superstar Andy Atherton, who will be demonstrating SensoPart's vision tools. And batting cleanup is Dan the Man Pelton, who will be showing you how to integrate your SensoPart camera into a Rockwell PLC. We will then close with our traditional Q&A. Please write your questions into the comment section as they come up throughout the presentation, and we will answer them at the end. Now, I would like to mention that our event producers will be canceling difficult questions that are too tough for our presenters to handle. Now, I encourage you to ask those complicated questions and put their feet to the fire a little. And it is very easy for me to say that as I am only responsible for reading the questions. With that, please take it away, Justin.
Hello, everyone. Welcome to the April KCL Spotlight. I am Justin, an automation specialist out of Kalamazoo, Michigan. And this Spotlight segment is to help familiarize you with products and services offered by Kendall Electric. So I have a few messages from the team before we get back to the show. Did you know we have a website and an app? Go to shop.kendallelectric.com 24/7 on your computer, tablet, or mobile phone. Easily place orders, check pricing and availability. You can view your open orders and invoicing, but if you don't have an account, it's not a problem. Simply click sign up to register. Or check out our OE Touch app for the same functionality as our website. This app is available for both iOS and Android devices. Search your app store for Kendall Electric OE Touch. Both are great options to browse your Kendall at your convenience. From our services team, at Kendall Electric, we don't just repair, we remanufacture. Do you need a quick turnaround on a failed HMI? We have your solution. Do you need to remanufacture that old spare drive in the tool crib? We also have your solution. We restore failed and aged automation products to like new using original OEM parts, following a proprietary process and performed within ISO certified facilities. For those safety devices, we also maintain safety device performance certifications on any safety-related automation product. Remanufacturing services offer cost-saving solutions as compared to purchasing new components and can extend the life of existing automation investments. Cybersecurity is one that'll sneak up on facilities of any size. Kendall Connected Solutions has an answer to cybersecurity and cyber risk management. Whether your objectives involve design, build, sustainability, or improvement, Kendall Electric and our partners can help take your factory floor from concept to future state. Kendall Connected Solutions can help your team identify cybersecurity risks within industrial networks. We offer thorough identification of key network characteristics, such as critical vulnerabilities, unsupported operating systems, and existing network communication analysis. Our team of industry professionals provides cyber risk identification and management solutions. At Kendall Connected Solutions, we deliver quality, performance, safety, and security. We deliver you solutions. This KCL will be posted for future reference on the Kendall Electric YouTube channel. If you have any questions on repair services, if you would like a network security assessment, or if you have any questions about today's content, contact your local Kendall store, account manager, or automation specialist.
Thanks, and hello everyone. My name is Randy Carlson. I am one of the Kendall Electric automation specialists here in the Grand Rapids, Michigan office. Today I want to take just a couple of moments to discuss with you the SensoPart Visor product line. There are many models within the Visor product line. They primarily break down based upon the resolution of the sensor, the software tool set that it contains, the style of the camera body, and then also whether the sensor is a color or monochrome type chip. Here you see a picture of what we call the integrated camera body. On the left-hand side, you see the front face of the camera, and you can see the LEDs that are used for illumination built into the face of the camera. Inside of the camera body is the S-mount M12 style lens. The picture on the right-hand side shows you the back side of the camera. There you'll see two ports. The port on the left is the way that we power up the camera with 24-volt DC. We also provide discrete inputs and outputs through that port. The port on the right is the LAN port. This is where we accomplish our network communications. For the factory automation protocols, the camera supports Ethernet IP and Profinet. Additionally, for those applications where it's important that we archive images that the camera has taken, that port will support FTP, or File Transfer Protocol, because sometimes we want to capture those images, analyze them, but then also load them to a network drive to save them for later analysis or archival purposes. And then additionally, when we program the camera, like Andy's going to be showing you pretty quickly, with the SensoConfig software, we utilize TCP/IP protocol for communications with the configuration software. Here we see the 3 resolutions that the Visor product family supports. There are multiple models within each one of these designations. The V10 is the standard resolution. That's an 800 by 600 pixel chip, and that works out to just short of a 0.5 megapixel. The medium resolution is a 1.5 megapixel. That works out to 1440 by 1080. And then the high resolution chip is the 5 megapixel. That is a 2560 by 1936 pixel array. And those we designate as the V50s. The tool sets are another way that we differentiate the different camera models. When I say tool set, I'm speaking of the different software algorithms that are available in the camera for supporting the different inspection tasks. They break down into 4 general categories: the all-around, the object, the robotic, and the code reader. As you might expect, the all-around are examples of cameras that support and have all available inspection detectors. The object category are for those general inspections where we're doing part identification or part detection or feature and characteristic detection. The robotic category is used in those applications where we integrate the camera with a robot for robot guidance purposes. Sometimes the parts that the robot needs to pick up might be randomly located on a conveyor belt, or they may be in a fixture or a tray, but they are not held very repeatably accurately in the same position each time. In those cases, we can use a camera to take a picture, and within the field of view, the camera can identify very precisely the position of the part, its X, its Y, and its rotation, and report that information to the robot so it can do a good job of picking up the part. This category of cameras has a similar tool set to the all-around, but we also provide additional focus on calibration tools, because in this case, it's very important that the camera field of view be calibrated so that it can report as accurately as possible the position of the part to the robot. And the final general category is the code reader category. Those models contain the tool sets for performing 1D and 2D barcode reading, and also OCR, or optical character recognition. In those applications, the camera is taught to read human readable characters. Many times we are printing directly on the product or directly on the packaging, date codes, lot codes, manufacturing codes, and the camera can be taught to read those different characters. Sometimes those characters are inkjet printed, sometimes they're laser marked on the product, sometimes they are dot peened onto a product. So there are many different applications for doing optical character recognition. This slide shows you the 2 different camera body styles that are available. The picture on the left is that integrated camera body style that I showed you earlier. The picture on the right is an example of what we call the C-mount camera body. In this case, we're able to thread onto the camera face C-mount lenses. There are a wide variety of manufacturers of C-mount lenses with many different focal lengths. So this gives us the most flexibility when we need to position the camera close to objects or further away from the objects that we are inspecting. Additionally, in some of our applications, we need to perform tolerance checking or dimensional gauging, and the telecentric lenses that are available in a C-mount format are the most accurate optics for doing tight and accurate dimensional gauging applications. And finally, one more way that we differentiate the different models is based upon the number of jobs and the number of detectors that the model supports. There are 3 different variants: the standard, the advanced, and the professional. As you can see here, the standard object style sensor will support 32 jobs and 32 detectors per job, and a standard code reader will support 8 jobs and 2 detectors per job. The advanced and the professional add additional capabilities. The professional is the range of models that provides the most flexibility. It supports the most jobs and the most detectors, and it will have the widest tool set. So right about now, you're thinking, wow, I have to decide between whether it's monochrome or color. I have to determine what resolution I'm going to use, what tool set I need, what camera body style is best, how many jobs and detectors do I need. But that's where we come in. So Kendall can assist you by determining what are the appropriate requirements for your application, and we can choose what the best camera model is for you. And with that, I will turn it over to Andy for his first demonstration. Take it away, Andy.
Hey, Randy. Thanks for that overview of the SensoPart Visor product. My name is Andy Atherton, an automation specialist here at Kendall Electric. Today, I'd like to give you a quick demonstration of some of the capabilities of the SensoPart Visor family. As Randy mentioned, the Visor family comprises several types, including a code reader. First, I want to show you the strength of the code reading algorithms. I have a sample sheet with some data matrix codes and a couple of EAN codes. The data matrix codes include codes that are damaged, both finder and clocking patterns, and one with a severe quiet zone violation. I am using a Visor V10 all-round, which has an 800 by 600 pixel image chip. This unit has the medium angle of view lens and red integrated light, and it is placed about 13.5 inches away from the sample sheet. I'll place the sheet in the field of view, click the auto exposure and the auto focus. Next, I'll add a 2D code detector and name it DM code. Right away it reads one of the codes. I have 6 codes, so I'll set it to read 6, and now it reads 3 of them. Then I will click the Teach button. Now all 6 codes are read. Next, I will add a barcode detector and name it EAN code. An EAN code is like a UPC code, except it is used outside of the US and Canada. I will set it to read 2 codes. Now both codes are read. Reading codes printed on paper is not specifically difficult. So let's try reading pin-stamped codes on metal. I will remove the paper sheet and place a metal plate in its place. It has 2 well-formed codes, one that is damaged and one that is undermarked. When I click the Teach button again, all 4 codes on the metal plate are read. I can go back to the paper sheet and see that those codes are still read also. This demo should give you an idea of the strength of the code reading algorithms in Visor Code Reader. It can read significantly damaged codes, and without any special lighting, dot-peened codes on metal, even if they are not ideal. Another of the types of visor is the robotic, which has a new detector called Contour 3D. This detector is trained on a model whose contour lies in a 2D plane and is able to locate the contour in 3D space. I'd like to demonstrate this to you. I have a coffee cup with the Kendall logo to use as the contour. I also have a V20 All-Round Professional, which has the Contour 3D tool, fitted with a 12mm C-mount lens, and externally an LM75 light from Smart Vision lights. This could also be done with a model with an integrated lens and light, if appropriate to the application. I start by creating a new job, enabling the external illumination, putting the part in place, adjusting the exposure time, and the focus. Then the system needs to be calibrated. I will use a SensoPart calibration grid and perform a multi-image calibration. First, click the Calibration tab and select Calibration Plate Robotics. Then click the Next Step arrow. I will change the calibration plate selection to the plate I will be using. Set the Z shift to 1 mm, which is the thickness of the grid, and set the focal length of the lens to 12 mm. Select Multi-Image Calibration and click Start Calibration. This opens a dialog box where you can add images either through manual triggering or continuous triggering. If an image is not acceptable, you can delete it. When all of the indicators have turned green, sufficient information has been gathered to produce the calibration. Click Apply and the dialog closes. The indicator on the Calibration tab should be green. Next, click on the detector step. When the detector list opens, select Contour 3D and click OK. Then, resize the search and the model regions. Adjust the threshold, angle range, distance range, and tilt range to meet your application needs. I can also edit the contour to remove unwanted pixels in the model. Next, I go to the Result Offset tab, select Robot 3D, and I can adjust the pick point to something other than the geometric center of the contour. I can adjust the location in the X, Y, and Z axes and rotation about the X, Y, and Z axes to optimize how a robot gripper would pick up the part. Now as I trigger the system and move the part, the pick point is found, and the X, Y, Z, angle X, angle Y, and angle Z data is provided. I can even move the part closer to and further from visor, and the pick point will be recorded. This detector allows locating a part that may not be presented to visor in a consistent manner. It tolerates changes in location in 3D space and rotation around all three axes. The pick point of the object does not need to be in the same plane as the trained contour. All this from a vision sensor that is a fraction of the cost of a 3D vision system, and achieved as easily as setting up anyone else's vision sensor. While the detectors I have shown are certainly impressive, they are not the only detectors available with Visor. Let's see what else Visor has to offer. The OCR detector can read human-readable text, whether a single line or multiple lines. Character extraction is achieved by the sizing of a bounding box around a character in the string. Pre-trained fonts offer the ability to read most fonts and saves the time-consuming process of training one. The pattern matching detector is as capable and accurate as anyone else's. It is capable of detecting multiple instances of a pattern, even on a noisy background. In addition to the Contour 3D detector, there is a standard contour detector for detecting models in 2D space, which can be used for detection or identification. The contrast, brightness, and gray detectors are histogram-based and detect the presence of contrast in a region, intensity value within a region, and the number of pixels within a grayscale range in a region, respectively. The caliper detector is used for edge detection and measurement of distances between two edges, whether they are opposed or aligned. The blob detector can find consistent or inconsistently shaped and sized objects and provides the ability to extract information from the found blobs, including the radius of circles, variations in the edges of circles, and even being able to detect if an object is face up or face down. Finally, the new result processing detector allows extracting information from other detectors, both values and strings, and manipulating that data to create custom tests or custom values in string identification. Though not detectors, there are also image processing filters for adjusting and improving less than ideal images prior to application of detectors. This is a brief overview of the detectors available in Visor, but the capabilities go beyond what has been demonstrated here. Not all detectors are available in all types and variants of Visor, but this allows SensoPart and Kendall to offer cost-competitive solutions for your applications. Next, Dan Pelton will discuss the communication options available with Visor and demonstrate integrating a Visor into a PLC program.
Thanks, Andy, for that awesome demonstration of the SensoPart Visor software and the powerful vision and ID tools. Now let's get into the PLC integration of a Visor vision system. I will introduce you to the various communication interfaces available and provide a demonstration so that you will be comfortable integrating your next SensoPart vision system. The available communication interfaces allow for flexible and simple connections to PC applications and programmable controller environments. For PC applications like Visual Basic or LabVIEW, Ethernet TCP/IP can be used. For industrial protocols, the first supported is Ethernet IP. I will be demonstrating this for you today to a Logix controller. As a note, explicit messaging can also be used with MicroLogix or Micro 800 systems to communicate to a Visor system. Also supported for Siemens or Beckhoff is the Profinet protocol. For simple applications where maybe all you need is a pass or a fail signal, you can utilize the digital I/O channels. An additional noted interface is File Transfer Protocol for archiving of captured images. Finally, there is a SensoWeb interface that can be used to monitor your running system. This is easily accessed with a web browser by pointing to your vision system. Here you can obtain pass and fail counts, as well as monitoring the image and tools of your running system. In today's demonstration, I will be connecting a Visor V20 all-round camera and a Rockwell Automation Compact Logix 5380 controller. This communication will utilize Ethernet IP, and I will also connect up a computer running the Visor software to set up the Visor communication, along with Studio 5000 to program the controller. Let's get started. The first part of the configuration is to set up the Visor software. We'll continue with Andy's application from earlier in the barcodes. We'll proceed to the next step, which is output, and first we'll need to enable Ethernet IP. Once this is enabled, we'll need to identify the telegram or information being sent to the PLC from the camera. A prefix of 010 is necessary for the add-on instruction we'll be adding to the logic later. Next, we're going to identify the payload or information being sent to the PLC. We're going to choose our data matrix code, and then we're going to choose the overall result. Next, we're going to add the detector again, data matrix code, and then we're going to choose a value of string length. Finally, we're going to add the data matrix code again and choose the value string content itself. Finally, we're going to start the sensor and get it ready for communication. Now we're going to use Studio 5000 Logix Designer to create our PLC program. We need to create a new project and assign it a name. We're going to use KCL Demo and choose Next. For this, we're going to be using revision 32. and then we can choose Finish. Once our project is open, we can install the EDS files required. This is accomplished through the Tools menu and EDS Hardware Installation tool. Once it's open, you can choose Next to register an EDS file, and then we can browse to the location of the EDS file. And then we can choose Open. You can confirm the icon is correct for the visor vision sensor and choose Next, Next again, and then we'll finish. Now that this is completed, we can add our visor into our I/O configuration by right-clicking on Ethernet and choosing New Module. Here we can enter search criteria for visor, bringing up our visor vision sensor, and choose Create. A couple of key settings here to enter is assigning a name, assigning an IP address, and also we need to change the module definition data size. For the code reader, we're going to want to choose 2 plus 64 bytes. This is 1 control byte, 1 status byte, and 64 bytes of data. Choose OK, and then Yes to change the module definition. Next step will be to add our add-on instruction. This can be done through the Assets and the add-on instructions, right-clicking and choosing Import. We're going to browse to our add-on instructions file and choose Open. Now you're prompted with a dialog to make any changes necessary to the import. For this instance, we're going to leave all defaults and just choose OK. Now that the add-on instruction was added, we can choose our routine, and from the Add-on tab, we can drag and drop our visor code reader instruction and start assigning the necessary tags. Once the tags are entered into the instruction, we can download the program, choosing Communication, Who Active, then we can choose our driver, and then our controller, and finally Download. Now you can put the controller into run mode by choosing Yes. So we only have one job number in the visor, so we can enter a job number of 1, and then we can issue a start command. You'll notice that the code was red. If we monitor our results string, we can see that our PLC tag data now shows SensoPart, which was the content of the first data matrix code. You'll also notice in the input tag, the raw data is formatted how we set up our payload in the visor software. Here you can see the overall results of a 1, a string length of 9, and our code content SensoPart. So now you've seen how easy it is to set up and configure the PLC integration of a SensoPart vision system. There are a few really good references available from SensoPart. The communication manual and step-by-step instructions guide walk you through the demonstration I provided today, along with passing vision tool information to the PLC as well, not just barcode. Next up is Randy Carlson, who's going to wrap up our conversation and discussion.
Okay, thanks Andy and Dan for those demonstrations. Now, before I turn it over to John to handle the question and answer session, I have just 2 slides to cover a wrap up and a couple key takeaways. And those key takeaways are vision experience. Kendall Electric has been selling machine vision systems for over 15 years. So we have helped many customers solve their inspection applications. A broad range of vision sensors. As you saw in my previous presentation, SensoPart has many models to choose from, so we're able to pick the appropriate camera system for your specific application. A vision evaluation service. By sitting down with you and understanding the requirements of your application, understanding what physical constraints you might have, determining the pass-fail criteria, and gathering samples from you, we can conduct a feasibility study, and the output of that feasibility study will be a document that describes to you in detail how we went about solving your application and will help list the components that we used to solve the application. Machine vision is usually just one piece of the total solution. Usually after the camera performs its inspection, it then needs to pass that information to another control device. It could be passing that information to a robot for robot guidance purposes. It could be passing the information to a PLC to take further control system actions. Or you might be headed down that digital transformation journey and you're taking the data from the plant floor up through the control system into your enterprise system to use for process improvements or data archival purposes. And then finally, lighting, optics, enclosures, and mounting solutions. In my next slide, we'll cover some of those solutions we have. And finally, this slide gives you an example of some of the different partners we've worked with to provide a complete vision inspection solution for you. From a lensing and optics standpoint, we've worked with Edmund Optics and Opto Engineering, just to name a couple. For our lighting needs, we've worked with CCS America, Advanced Illumination, Smart Vision Lights, and there are others. It depends upon the illumination requirements of your application as to which manufacturer is going to provide the best lighting for you. For filtering, we've worked for a long time with Midwest Optics. For enclosures, Allison Park Group, or APG, is a vendor we work with. They have designed enclosures specifically for cameras. And then also Swivel Inc. Swivel Inc. provides many different mounting solutions and brackets for both your cameras and for your lighting. And with that, I'll turn it over to John Bain to handle the question and answer session. Thank you.
Hey, thanks, Randy. All right, moving on for the first question. First 2 questions, actually, both are based on where the add-on profile and EDS files can be located for the SensoPart cameras. Mr. Pelton, can you take care of that question?
Sure, absolutely. Thanks, John. Yeah, so basically all the free downloads and configuration files available from SensoPart. I guess I'd start at the sensopart.com website because there you're going to find the PC software necessary to program the visors. And then once that's downloaded and installed, there will be some locations like the program files, x86, SensoPart, where then you can go specifically to install that EDS file I demonstrated, as well as the add-on instructions necessary. Again, for free.
Awesome. Thank you, Dan. Are all of your evaluations free? Randy, can you outline our process and if there's any cost associated, please?
Yep, sure can. We've provided evaluations and feasibility studies for many years for our vision applications. What we'd like to do is have one of us come out and visit with you and sit down and understand what the requirements of your application is, talk about your physical constraints that you might have of where we can mount cameras and lighting and whatnot, and hopefully be able to gather some samples from you. Ideally, some examples of good parts, some examples of bad parts, and maybe a couple examples of those marginal parts. And with that information, we're able to submit that and the samples to our vision lab in Grand Rapids, and Andy can perform that evaluation. And during the course of that evaluation and feasibility, he will choose what the appropriate camera, the appropriate optics and lighting is. And part of that testing, he will be able to capture some images. So the output of that testing will be a document that shows you what we propose as the most robust solution. It will identify the components, and then Andy will also embed in that evaluation document some of the images he captured from the camera, and that gives us the ability to sit down with you and kind of review what we think are the important things to keep in mind for your application. And again, that's something that we provide free of charge for our customers.
Thanks for that detail, Randy, sorry. Next question. Will this camera work with my installed Slick and MicroLogic 1400 controllers? Andy, can you answer that for us, please?
I certainly can. In addition to doing implicit messaging to the compact and control objects units, the SensoPart visor can also do explicit messaging to Slick 505s, MicroLogics with Ethernet built in, and even the Micro 800s with Ethernet built in.
Awesome, thank you. Next question. What are the color options for the built-in lights? Randy, you want to take that one?
Sure, I can take that one, John. Yeah, currently there are 3 options for the integrated lights. That is a white light, a red light, and an infrared light.
Thank you. Are the mounting brackets available, or how is a visor typically mounted?
Yeah, I guess I can take that one as well. There are a few different mounting bracket options that SensoPart provides. The bottom of the camera body has a V-shaped extrusion that you're able to clamp onto with a bracket, and they do have a few different versions of that bracket. Additionally, we also use Swivel Link, which also has some bracketry that's very useful for mounting of the cameras and the lights.
Awesome. Are any visors available with PoE? Andy,
And I guess I'll take that.
I can take.
Oh, go ahead, Andy.
Yeah, I can take that. No, all of the visors run off of 24-volt DC. PoE is not an option.
Thank you. Is the programming software for the SensoPart camera free? Andy, you want to take that one?
Yeah, as Dan mentioned, you can download it for free from the SensoPart website. You do have to create a login in order to get it, but there is no charge to do that.
Thank you. The next question was the same. You guys already covered that. Can I get a demo unit for testing? Randy, you want to touch base on any demo possibilities we offer?
Sure. As a distributor for SensoPart, we have a number of different demo units that we have spread out across some of the different offices. So we do have availability to get a demo unit into your hands, so we can provide you with the camera, the cabling that's necessary, and we also have availability of some lighting as well. So we can get that into your hands and help you set it up and start working with it and doing some testing.
If I can add to that as well, if we don't have the specific model that you're looking for, we can also get units from SensoPart themselves to get you something really more specific than what we would have as demos.
Thanks, guys. And the last question in the queue, I know we got 2 more. Does Kendall do any on-site testing? Randy or Mr. Pelton, you guys want to take that one?
Yeah, I can
Sure.
jump in. I'll jump in on that. You know, we typically, as our first step, we do the feasibility study in the lab. And during the course of that, Andy does a really good job of taking a look at what are all the different scenarios that can happen out in the real world, some of those production variables. So we're pretty confident with the testing that he does in the lab that if we approach it and deploy it with that approach, we're going to be as successful with an implementation. So most of the time we do not need to do any on-site testing. That doesn't mean that there aren't specific situations where, you know, you may have some samples that we just can't bring into the lab to do testing in a lab environment. You know, we can certainly handle those on a case-by-case basis. It's not out of the question to try and set up and do some testing on site.
Thanks, Randy. And the last question in the current queue, is there any way to view images on an HMI such as a panel view? Dan, can you answer that?
Sure. As I mentioned there, one of the capabilities with these products is the SensoWeb. So that would be our portal into the camera just by going into a web browser, typing an IP address of the SensoPart camera, and bringing up that SensoWeb interface. Unfortunately, I have struggled to get the panel view web browser, the ActiveX web browser, to view that screen successfully. So I would recommend either a PC-based HMI solution that does have an embedded web browser that might be Microsoft or Google Chrome or Mozilla or something like that, where it is specifically a web browser dedicated to that SensoWeb interface. Just from experience, we've struggled a little bit with the panel views, still working with SensoPart and their engineering team to help resolve that.
Thanks, Dan. I'll give you guys a few more seconds to enter any questions, any last minute questions that you guys want to discuss and ask the specialist.
Yeah, one other addition to John, just as I was rereading the question, there is also a purpose-built display. It's actually a PC that is available for the SensoPart systems. So it's actually like I mentioned, has a Microsoft operating system on it, so you can actually run the SensoConfig software. You can actually run the SensoWeb interface from a web browser on it, or even the SensoView, which is another interface into your system. So that purpose-built PC is an accessory that we would also recommend for any system that you might deploy.
Got it. Thank you. Looks like we are all done with the questions.